Today we're going to look at compound interest, and we're just going to look at solving for future value. So now that we're into the finance unit, let's make sure we know some of our words. So interest is our capital I, that's money earned or the additional money owed on a loan. So that's the cost of borrowing somebody else's money. Principal is our P, that's our original amount of money invested or borrowed. That's also called our present value. A is our final amount, that's our future value. So we've got other words that happen in here too, depending on where you're looking. So principal is also our present value. Amount is also our future value. Interest rate is our rate, that's our little r. It's a percentage written as a decimal. So remember, to go from a percentage to a decimal, you have to divide it by 100. Term is T, that's the length of time, and it always has to be in years. We're going to look at compound interest today, which is calculated using the principal and the previously accumulated interest. So that means that interest is happening on top of interest. And the compounding period is how often the interest is added to the principal before the next interest is calculated, okay? So that's like our frequency in 1 year, okay? So what are we talking about here? When money is borrowed or invested, the interest is added on the principal after a certain period of time. After the same period of time, interest is then calculated again, and this time it is calculated on the new amount, which includes the principal and the interest. This procedure continues for the entire term of the loan or investment. Tomorrow's lesson, I show you that on a spreadsheet and a graph as to how that works. Today we're going to look at the equations. So we've got A, so our future value, which is our final amount. We've got a P, which is our principal or initial amount, our present value, our starting amount, whatever. Little I is the interest rate divided by the number of compounding periods. So little I is our interest rate as a decimal divided by a number of compounding periods. Little n is the total number of compounding periods. So little n, that's our exponent. So number of years times my number of compounds per year. And every question is always, you're always going to see the words compounding something. Something, and that something is going to tell you what n equals, okay? So don't forget I is just the r over n. And what are these n's? So there's all these really cool words that we're going to start seeing. So if you see the word annual, interest is paid once a year, so your n will be 1. Period is semi-annual, that means you are being paid twice a year, so that's 2. That's what semi means, is twice. Quarterly, well, that's just 4 times a year. Monthly, well, once a month, and we've got 12 months in a year. Weekly, I'm going to drop down to that. Well, we've got 52 weeks in a year. Bi-weekly, bi means every other. So it's happening every other week. So that means, 56 divided by 2 gives me 56. What am I doing here? Got the answer stuck in my head and we haven't even made it through the question. 52 weeks in a year divided by 2 is 26. Oh, see, there's that 6. Sorry. 26. Daily, well, we've got 365 days in a year. So then n would be that. That's what cash advances on credit cards charge you, which is pretty big. So watch out. They'll get you real bad on that one. Okay, now that we know those words, let's do some calculations. So I know that the main formula is A equals P bracket 1 plus I to the little n. And I want to figure out what these values are, and then we're going to solve. So I got 2 scenarios here, nice straightforward scenarios. Let's not forget that I is equal to little r over big N, and little n is time in years times big N. Okay, so let's see, what do we got? Mary is going to invest $500, so there's my starting amount. Time is 5 years, so there's my time. Where's time over here? There's 10. Good. At 8%, so there's my interest rate as a decimal. So we got to divide that by 100. 0.08. And these big magical words here, compounded semi-annually. So semi-annually means it's happening 2 times a year. So that shows up in our formulas twice. Okay, so that means, let's see, P is our 500, don't have to do anything with that. Little I is 0.8 divided by 2, so that's our 0.4. And little n is going to equal to 10. So when I go to throw everything into the equation, a equals p bracket 1 plus I to the exponent n. Well, p is my starting amount. 1 plus 0.4 to the exponent 10. Calculator, please. Order of operations. Simplify what's in your bracket first. And then you do your exponent. 1.04 to the exponent 10. So that gives you a really big long decimal. And rounding makes a big difference in these things. So try not to lose your decimals, please. You can generally do this without clearing your calculator. Calculators can really handle this all in one step, depending on your calculator. I don't trust cell phone calculators, and some of them have a different order of operations than you're expecting. But there you go. Therefore, final amount is $740.12. Ta-da! Look at that. It's gorgeous. Okay. So let's try it with another one. Oops. So here we've got Raymond. He's going to borrow $300. So he's going to borrow $300. That's my starting amount. There's my 300. We've got a time of 3 years. We have an interest rate of 0.05. Remember, turn that into a decimal, right? Percent divided by 100 turns it into a decimal. And the magical words on this one are compounded quarterly. And quarterly means it happens 4 times a year. So let's see. I is equal to R over big N. So that'll be 0.05 over 4. Little n is T times big N. So that is going to be equal to 3 times 4. So what's that? 12. 0.05 divided by 4. Does that work out easily? Oh, that works out pretty good. So little I is 0.0125. There's P. Let's do this. A equals P bracket 1 plus I to the exponent N equals $300 is what we start with. 1 plus 0.0125 because we're increasing by that. All to the exponent 12 because it's happening 12 times. Simplify what's inside your brackets first. Please, always. And then, yeah, you can probably calculate all that at once. 300 times 1.0125 exponent button 12. Depending on your calculator, depends on how well it'll do this. And that would round up to 23. So there you go. Mary went for longer, Raymond went for less time. Therefore, final amount is $340.23. So let's add on to our question here a little bit. What's my interest earned? Or paid? I forget the question. So make sure your interest, remember, is going to be the difference between what you end with minus what you start with. So in our first example, we ended with $740.12 and we started with $500. So our interest earned here would be $240.12. Second one, our interest would be our final amount minus our starting amount. We end with $348.23. We started with $300. So this one earned $48.23 in interest. Okay, so now we're going to keep going with the same kind of equation, only we might have to do a little rearranging here. Let's look. All right, what do we got? We got how long, oh, right there, that means that T is going to equal to the question mark. Would it take $500 to turn into $1,500? You have 6% per annum compounded weekly. So let's go back. How long, so we're looking for a time, would it take to turn $500, what we're going to start with, into a final amount of $1,500? We have an interest rate of 0.06 and compounded weekly, we got 52 weeks in a year. Okay, so I like to list everything down the side. I'm starting with 500. Hang on, I need more space here. I remember is R over N. So that would be our 0.06 over 52. And our little n is time times big N. And our time was what? Oh, that's our question mark. Okay. Well, let's see. A equals P bracket 1 plus I to the exponent N. A is 1500, P is 500, 1 plus I is 0.06 over 52, and we don't know what the exponent is. All right, let's simplify what's inside our brackets, because let's simplify what we know. 1 point, let's see, 0.06 divided by 52 gives me a big long decimal. 0.0115384 all to the exponent n. Now do not, under any circumstances, stick your 500 in on there. This is a separate number. It is off limits for right now because it is attached to that exponent. So this is off limits for right now. You can divide both sides by 500 because that's the opposite of timesing. So we can most certainly do that. And then 1500 divided by 500, well, that's 3, equals 1.001153846 to the exponent n. And the only way we can do this with our current skills is we have to do some educated guess and check. Educated guess and check. Right? Trial and error. You cannot go further than that with the skills that we are learning in this course, so please don't. Okay? So that means I need to type in that number into my calculator, and I need to come up with some kind of random exponent. So don't forget the n is 52, right? So the n is 52. So I'm going to need a big number for that. So I don't know. What happens if my exponent is equal to 100? What does all of that equal? 3, 8, 4, 6. What does that equal? I don't know. Exponent 100. 1.12. No, we're nowhere close. Okay, bigger number. Let's do n equals, I don't know, 300. Sure. So that means 1.001153846 exponent. Oops, 300. What does that give me? 1.4. We got to get a lot bigger than that. Let's try 500. What'll that give me? So I did everything to the 300. Now let's do that everything. So 1.001153846 to the exponent 500. I don't know. Let's see what that gives me. 1.001153846 exponent 500. Oh, that's only 1.78. Goodness gracious me. We got to get way bigger than this. Let's try 1,000. 0.001153846 exponent 1,000. Oh, so close. Yes. 1.53846 to the 1,000. Now we're looking. 3.168. And you know what? For us, that's close enough. So I'm going to go with this. Okay, close enough. You can learn how to find more exact answers next year, not this year. So to find our time, we now have to go back to this to figure out our time. Okay, so we have to go back to n equals t times big N. So little n, we're going to say now is 1,000. We're looking for our time, and we knew it was 52 weeks in a year. So rearrange, let's see, divide by 52, divide by 52. So time is going to be equal to, 19.2. Therefore, it will take approximately 19 years. Because that was a little bit bigger, right? So let's just say 19 years and we got it. right? Right. Perfect. So there we go. So we subbed it, we figured out our values, we subbed in what we could, we simplified following proper order of operation math numbers, we moved our 500 to the other side, we got a goal, and then we tested different exponents, oops, to get something close to our goal. Well done. All right, let's look at some real world examples. So I went online, I looked at Best Buy, checked out their flyer, took a little screenshot here, and they're selling a 65-inch TV for just over $1,000. That's pretty good. They offer some financing. You can choose to pay over in a great timeline, interest-free. That sounds pretty good, right? But let's see if we can't figure out a few important things that we need to know about that. So if you paid on time, you pay the tax, but you just basically pay the cost, right? So we have to worry about tax. So remember, tax is 13%. Okay. So that means my total cost would be the price, price, times the 1.13, right? Turn your tax into a decimal, and then we have to plus it to 1 to get our total, and then we don't have to do like 5 different calculations here. 1199.99 times 1.13, and then this will tell us our total purchase price. So when the bell goes ding ding, this is it. 1199.99 times 1.13. What's that? $1,355.99. So assuming we pay everything on time and there's no other fees and stuff, which I couldn't find any fees online when I was looking, but I did look, we're looking at approximately $1,000, $355.99. Okay, but if you don't pay it on time, so if you pay it even 1 second late, okay, even 1 second late, they are charging you, oops, that's a D, 21.9% interest. Compounded monthly, and that's what they're going to backtrack for that whole year or 2 years that you were planning on paying it for. Like, it's insane. So let's see what that's going to turn out. So instead of using our equation, which we can totally do, I'm going to introduce you to one of the online calculators, and we're going to use that to kind of see how things are looking. So when we go to type things in, we have to put in our present value, right? So that's going to be our purchase price with the tax included. So we're going to type in 1355.99. Ignore payments for now. Okay. Future value, well, this is what we're looking for. Annual interest rate, so we leave it as a percentage, 21.9. And periods, well, that's our little n. Okay. So that's our T times n. So if we assume that we're going to pay it off in 1 year, well, we've got the monthly, so there's my n value. So we've got 12 periods, okay? And we're doing monthly, so we're going to leave this as is. So let's see what that looks like. Okay, so here's my online calculator. Let's type it in. We've got 1355.99. Interest rate is 21.9. Periods is 12. And we click on future value, and look at that. Now we've got our answer. Pretty cool, eh? So our future value is $1,684.65. Click for answer. So that's a lot more money. If we were just like 1 second late, we now have to pay an extra $330 in interest. That's a lot of money. Okay, so my last real life example is really, really important. So whether or not we get through annuities later, this is technically more of an annuity because we do our payments. However, it's still including compound interest. So let's really see like the effect of compound interest over time. So when I called one of the local dealerships, I did this about 5 years ago, and I talked with them in a very important conversation. Lots of young people come in to buy a vehicle, and they either don't qualify or charge up to 30% interest because you have no credit rating. Or you did something you shouldn't have, and now you've got terrible credit rating. Okay, interest rates vary considerably depending on whether it's a used car, a new car, the style of car, all the rest of it. And so they quote what they would offer somebody with a good credit score. Okay, so what we're going to do is we're going to buy a car. So let's say that our car is going to be worth the $19,995. Okay, Let's do this times our purchase price to figure out what we're actually being charged here, because you got to pay tax. Okay, so we've got 19,995 times 1.13 equals, so with tax, we're looking at $22,594.35. Down payment, I don't know, pick a value. Let's say at $1,000. Sure. So then my present value, take off 1,000 from there, is really going to be 21,594.35. Okay, so that's what I'm going to enter in for present value on each of my scenarios. We're going to use the solver with a couple of different interest rates just to see what this really means for us as a purchaser, as a person, right? So our present value is 21,594.35. So that's going to be the same all the way across, okay, depending on our scenario, because that's what the vehicle costs. Okay, we're going to calculate our payment. So this is what we're going to calculate. We're going to assume future value of 0 because that means we've paid it off. Okay, so future value equals 0 because we've paid it off. Because paid off. Okay, our annual interest rate, that's the one that we're going to change each time. So we're going to start with 1.99%. And for our periods, let's say we're doing this for 5 years and we're doing monthly payments. Okay, that's a typical car loan. So let's do that. So that gives me 5 times 12, so 60. So each one of our questions, we're going to have 60 for our periods. Okay? So the only thing we really need to change is our interest rate. So let's see. Let's reset this one. We are starting with 21,594.35. Future value is 0 because we're paying it off. 1.99% because we have awesome credit rating. And we're doing it for 5 years times 12 months. So that's 60 payments in total. So when I go to click payment, well, that's not too bad. I can handle that. Can you handle that? I can handle that. So I have a payment of, what does that say? $378.41. That's pretty good. Okay. Well, second case scenario says you got a in-between credit rating. So it's not great, but it's not bad. 10%. Sure. 10%. Click on PMT, and what do we got? Oh, well, that's getting a bit more expensive. Now we're paying $458.82 per payment. Okay, so let's finish it off here. Oh, you've got a terrible credit rating or no credit rating. So you're being charged 30%. Oh, what are we going to have to pay? Oh my gosh, you're paying $700 a month. Practically, right? $698.65 a month. That's a ton of money. Like, how much is that really? I think we need to find out. So how much are you really paying? How much is coming out of your pocket? Well, you have to take your payments times, so the periods is how many payments you have to do. So, awesome credit rating, you're paying $378.41 every month. You're doing this for 60 months. I don't know, what does that equal? 378.41 times 60 equals $22,704.60. Oh, you're paying what, $1,000 in interest over 5 years? Oh yeah, that's fine. No biggie. Okay, what about scenario 2? So again, we have to do our payments times our periods, okay? Now we had to pay $458. So this is the in-between one times 60 payments. So let's see, 458.82 times 60 equals, now we're paying $27,529.20. So now we're paying $6,000 in interest. Yeah, that's not cheap. How about our worst case scenario? So when you walk in there and you've never had any kind of credit whatsoever, $698.65 times 60. I don't know. I don't know about this. Oh, $41,919. Holy cow, people. You're buying like a second car. Like you are now paying in interest. Let's see. Interest is our final amount start minus our starting amount. So there's your final amount right there. 41919 minus what was our original amount? I can't quite fit it on my screen here. 21594.35. Let's see. 21594.35. Oh yeah, you totally just bought a second car in interest. Interest payments alone just bought you a second car. Think about that as you make your purchasing decisions over the next several years of your life. Because that would follow you the rest of your life if you had that kind of bad credit rating. Or if you have no credit rating, you're buying a second car.